Well, hello, everyone. It looks like we'll still have a handful of people join us as the webinar goes, but we will get started to stay on time. So welcome to the fourth installment of the 2019 Stormwater Sessions Live series. I'm Ben Curtis. I'm with the Iowa Stormwater Education Partnership, and I'll be proctoring and monitoring today's webinar. As always, if you have questions during the webinar, go ahead and type them in the chat box or the question box, whatever's easier. We will answer those questions at the end. We'll leave probably 5 to 10 minutes to do that. If you're part of a group, just make sure someone from your office emails me a list of those in attendance so I can issue the professional development hours accordingly. In the next few days, I'll make sure to get the recording on our website where you can watch previous webinars as well. You can use that same link I had previously sent out in order to access the new recording. So today's topic is green infrastructure maintenance costs and new tools for making estimations with a case study from the city of Lancaster, Pennsylvania. We're joined today by Jane Clary from Wright Water Engineers in Denver, Colorado. Jane is a senior water resources scientist and VP of Wright Water and has been with the company for 25 years. Jane's work areas include watershed management, Clean Water Act related regulatory support for municipalities and industries. Jane serves as project manager for the International Stormwater BMP database and is a member of ASCE's Environmental and Water Resources Institute. Additionally, she was recently appointed by Colorado Governor John Hickenlooper to serve on the Colorado Water Quality Control Commission, where she has served the state for the past 3 years. So presenting with Jane today is Ruth Hawker with the city of Lancaster, Pennsylvania, where she is a stormwater program manager. Ruth holds a bachelor's degree in civil engineering technology from Pennsylvania College of Technology and a master's degree in environmental engineering from Pennsylvania State University. Ruth's expertise includes sustainable stormwater management design and municipal green infrastructure implementation. Ruth has over 10 years of water resource experience, including state regulation, regional watershed planning, consulting, and international design. I want to thank them both for taking some time to be here today and to deal with 3 different time zones as we're all across the country today. So thank you for both being with us today. And with that, I will hand it over to Jane.
All right. Thank you. And Ruth and I both appreciate the invitation to speak with you today. Let's see. I was going to, there you go. A little trouble advancing the first slide. The way that Ruth and I have divided this talk up today is I'm going to talk about some new tools that we have been working on together as part of a volunteer committee on the Municipal Water Infrastructure Council of the Environmental and Water Resources Institute of ASCE, better known as the MWIC Council. And then Ruth is going to use the second half of the talk to talk about some of her experiences working with the city of Lancaster and her efforts related to operation and maintenance of green infrastructure. So the way that our joint effort started is that the Municipal Water Infrastructure Council started trying to answer some questions about the cost of maintaining green infrastructure, which culminated in the book that's shown here. And then this project has grown, and so we're going to talk a little bit about the evolution of what we learned while working on that book, and then some steps forward here. So basically, in the 2015 time period, the MWIC Council did a national survey to look at what was going on nationally related to operation and maintenance of green infrastructure. And we learned some things about O&M costs, but we also identified quite a few data gaps during that research. And from there, we moved to a subsequent phase of the project to actually develop and refine some O&M reporting protocols for all types of BMPs, not just green infrastructure, and developed a list of reporting parameters and developed some data entry spreadsheets in Excel and have populated an initial cost database in Microsoft Access. And so we'll spend some time talking about those reporting protocols today. And then that part of the effort became associated with the International Stormwater BMP database. So we'll talk a little bit about that. And then also some example applications of these protocols related to a tablet application that can be used in the field with Survey 123, and then talk about how we're using some of the cost data that we've compiled in an EPA-funded grant project called Classic. We'll talk a little bit about the future direction of the cost database, and then we'll switch over to some just real-world experiences that Ruth has had in Pennsylvania. So when MWIC started working on this project, their committee was basically asking questions like, you know, what's the best way to track O&M requirements? How do you plan and budget for the whole life cycle cost of a BMP? What kind of metadata and BMP design characteristics need to be tracked as part of that maintenance information? And then looked at questions like, well, how do we track costs? Is this at a programmatic level, all lumped together? Or is there an ability to track costs at an individual facility level? When we're tracking costs at a more detailed level, what kinds of things need to be itemized in terms of labor, materials, disposal, traffic control, those kinds of things? And then some questions about tracking the kind of the three different categories of maintenance costs, your routine kind of preventative maintenance, corrective maintenance, and then your major rehabilitation and restoration efforts. So those were kind of the starting questions. So we made phone calls really all around the country, and I would say about half of the entities we contacted had data and information that they were able to share, and those are shown here on the map. And although there weren't a lot of locations, they were we had a pretty good distribution from around the country, and we did have a few communities associated with the Iowa Economic Development Authority, including DeBeck and Davenport, Iowa, and then your neighbor in Plymouth, Minnesota, that were able to share some data. So I'm going to touch a little bit on some of what we learned in this survey. And basically, everyone we talked to wanted the answer to the questions that we were asking. So there was a lot of interest in this topic nationally. So in some cases, we found that communities had asset management systems that in theory would enable them to provide data, but they really didn't know how to extract the data from those systems, or it was too time consuming, which then communicated to us that that data is probably not being used effectively to improve O&M programs and develop a better understanding of cost. In other cases, communities had lumped program budgets, but they couldn't really back those costs back down into individual BMP costs, like, for example, how does bioretention compare to extended detention basins? And then some communities had new green infrastructure programs and were expecting data but didn't have it at the time that we started working on the book. And then others really weren't collecting data and wanted some guidance on the types of protocols or parameters that they should be tracking. So some of the challenges that we had in the data sets that we got from the local governments that we spoke to were just a few of these are listed here. One is that some of them we were able to get maybe a total annual cost for maintaining a BMP, but we may not know how many times they went out to maintain that BMP. We had some trouble getting design metrics that we could normalize these national data sets to. Some communities track, say, the volume treated, others track surface area, particularly, say, for bioretention. And then there's some other variables that are really hard to track when you're normalizing a national cost data set. And those are things like, was the BMP properly sized for the tributary area that it's treating? Was it undersized where it needs more infrequent maintenance? Was it oversized where it needs less maintenance? So there's some things like that are really hard to capture in a cost synthesis like what we were doing. And then other things are, you know, if a local government provided data, we basically assumed that the frequency of monitor or maintenance that they were providing was about right, but in reality, it may have been inadequate, or it may be more frequent than would be typically done in some communities. Some of the other challenges that we've had when we've talked to cities is that sometimes the costs associated with maintenance are spread over multiple city departments and may include contract labor and may also include volunteer labor. And so sometimes it's hard to add up all of those different cost sources to get an overall cost for the maintenance of the BMP. And then some other site-specific issues would be, does the BMP have higher pollutant loading? Is it an area that's just really got heavy loading, or is it an area that doesn't need to be maintained as much because it's in a lower loading area? Is it out in front of your utility building where we're getting a lot of public exposure? Is it a demonstration project? Or is it somewhere in the back alley where maybe it's not being maintained as frequently? And so these are some of the variables, just a few examples of some of the variables that we thought about as we worked on this book. So we had hoped that we were going to have a lot of synthesized cost tables that would be great resources for communities around the country to use. And in reality, we had a much more limited data set, but we were able to do some basic data synthesis, at least for bioretention. And this graph here shows an example of some of the ways that we looked at cost, where we normalized the cost of bioretention to the square foot surface area of the facility, and we're able to plot some ranges of costs that we saw around the country, and you can see there's quite a bit of variability, and also kind of come down to some kind of median and mean cost estimates, such as 70 to 90 cents per square foot. So that's the kind of information we were able to glean from our survey research. One of the things that we did to kind of supplement those initial findings is that we summarized some of the cost estimating tools that are available that have been prepared by others around the country. And I'm not going to read through these, but the ones here in green are ones that have actual like Excel workbooks or web-based tools that you can use to develop whole life cycle costs. But basically, from that effort, we decided that the next step that we wanted to take was to provide better guidance to local communities on the types of information that they should be tracking and reporting related to operation and maintenance efforts. And this could be tracking done as a standalone kind of, Excel-based, local database type level of effort, or it could be protocols that a local government could use to customize their existing asset management tools. And so the recommended operation and maintenance activity and cost reporting parameters document shown here was created in response to the initial work we did in the MWIC book. And as a companion to this document, we created 2 Excel tools to record and track cost data. One is a basic tool where if you basically only have, say, an annual cost for a BMP, you could record costs that way. And then the second version was a full version that has more detailed cost reporting parameters. I'm going to walk through those in a minute. And then we also added in a basic capital cost form as well. And so our goals were to improve the tracking and cost of data nationally, and then start compiling data to better support maintenance planning. And then we've been able to use this information as part of this EPA-funded Classic project that I mentioned earlier. So the place that you can get this information is the BMP database website, bmpdatabase.org, and it's on the front page under the news section there. And so you can, at that link, you can download a zipped file that has the Excel spreadsheets, the user's guide, the initially populated database. And we're hoping that this database is going to keep growing because we're using it again on this EPA-funded grant. We're hoping that we can keep populating the database and keep it growing. So I'm going to give you a little bit of an overview of the structure of the database. The idea is that the information that we have could connect into or be part of an agency's asset management system, and could also be linked to performance monitoring data associated with the International Stormwater Monitoring Database, because I would say the holy grail would be to connect maintenance information with performance information and see how those two relate to each other. And so but we're not quite there yet, but that's kind of where we'd like to go. But the structure of the cost database basically has a couple of components. One is BMP facility information, and then we have a data table that's maintenance events, which would be basically what do you do when you go out to maintain the BMP. And then we have a set of tables that would be materials and quantities records that could be recorded. And our intent is to have the facility metadata that's needed to normalize costs around the country, or even within local government programs, and to be flexible enough to take annual summary costs if that's all that's available, but also to be able to take event-based, more detailed costs. And then we've tried to provide fields in these reporting protocols that enable linkage, again, to the BMP performance data and other parts of a local government's asset management system. Right now, this cost module is completely separate from the BMP database, other than the fact that you can link them together with these BMP IDs, but that may change in the future. So I'm going to just give you some snapshots of the tables that are in the reporting protocols. And again, you can go and download these and get detailed descriptions of these parameters from the website. But in the series of slides, I'm going to show now that the fields that are highlighted in gray in this table would be the minimum requirements that you need. But ideally, all of these itemized fields could help you to develop a better understanding of why certain facilities are costing more to maintain than others. So the first set of tables is basically the BMP metadata. Where is it? How old is the facility? What are the tributary area characteristics? What are the key design features that affect maintenance requirements? And then what are the minimizing, kind of normalizing design parameters that enable comparison, such as a surface area, or maybe it's a flow rate, say if it's a grass swale, or some sort of other type of water quality capture volume, treatment volume. And then other features like, does the facility have an underdrain? Does it have good pre-treatment? What kind of snow and ice management is going on at the site? Those kinds of parameters. The second set of tables would be the individual activity records, and there's a Part A and a Part B to these. The Part A would be information that you would record in the field, where you could record the dates that you go out, how many workers are out there, how long it's taking to maintain the facility, the level of effort, and then the items shown in blue on the right-hand side are actual activities that you could just have as a simple checkbox in a tablet application, and these activities would vary depending on the BMP type. The second part of that table would be what you would do in the office to connect the maintenance activity to work orders, contracts, that kind of thing, and actually connect the cost information to the activities that were conducted. And so we've provided some cost categories there, such as, labor, materials, equipment, disposal. Are you making one trip to a landfill? Or are you storing sediment in a central facility and then making one trip to the landfill, that kind of thing? Costs like traffic control can be significant for BMPs that are in the right of way or adjacent to roads. And then one of the issues that we've had with some of the local governments that we've worked with is the reality that contracts often include multiple BMPs, or the work order might include multiple BMPs. And so some thought is needed on how to split those costs out and allocate the cost among individual sites. So this is an example application of these reporting protocols that Holly Pisa at Mile High Flood District in Denver, formerly known as Urban Drainage and Flood Control District, put together. But she basically took the field maintenance reporting protocols and used Survey 123 for ArcGIS to give to her folks who go out in the field with the tablet app and record their maintenance information. And one of the things that she has said that this helped her with is just generally being more organized with maintenance, and it also helped with training, because the field staff that they use would often have questions about, well, what should I be recording in this particular field? And it would result in an educational opportunity to better describe the maintenance that needed to be conducted. So that's one application example. The next one that we want to talk about is Classic. It's Community-Enabled Lifecycle Analysis of Stormwater Infrastructure Costs, which is kind of a mouthful. But it's an EPA National Priorities Grant that is a platform that's being developed. It's almost to the beta testing stage. I think that'll happen this fall. And there's a team of folks, universities, nonprofits, consultants that are involved with this effort. But the intent of that tool is to utilize the life cycle cost framework to support evaluation of stormwater management alternatives, They include green infrastructure, hybrid, green-gray systems, and gray infrastructure. And so the cost database that I've been talking about is being used as a tool to help validate some of the cost algorithms that are being used in that tool. And so that's how we were able to initially populate this cost database. And so the information that's in the database right now started with some of the data that we obtained through the MWIC cost book. And then we added some capital cost data, in particular from the International Stormwater BMP database records that we already had. And then we had a couple of major cost data providers who had some pretty detailed records, and that included Capital Region Watershed District in Minnesota, the Puget Sound cost database that Herrera Consultants worked on for Washington State Department of Ecology, City of Grand Rapids, Michigan. And then we're working right now with the City of Austin to try to get their data sets in, but they are one of the governments that has had issues with multiple locations where cost information is recorded, and so it takes a couple of steps to add those up to get a cost synthesis. So I'm not going to go into detail about the analysis that we've done. I just want to give you kind of some examples of the direction that we're going with it. This would be an example of the capital cost data that we've put into the database, where we've normalized the data to 2018 dollars. This says 2019, actually, I just realized, but it's 2018 dollars. And normalize the data nationally. And then we're trying to develop some also further normalized related to capital costs per design parameters, such as surface area. And so, for example, here I have two graphs. The first one would be your filtration type BMPs like bioretention. And then the second graph shows your pond type BMPs, where we're hoping that we can get enough data here that we can use this information to help validate these cost algorithms that I mentioned earlier for Classic. In terms of the O&M cost part of the data set, this table on the right here shows you the number of data sets that we have for different BMP types. And you can see that we have a pretty decent sample size for bioretention, different types of manufactured devices, and basically wet ponds. And then the rest of the data sets are much lighter, with only a few records or locations each. But we do have data from about 12 states. Delaware had a lot of manufactured devices. North Carolina had a lot of bioretention and wetlands and retention ponds. And then Washington State had a variety of different types of practices. And so we're taking those data sets and we're synthesizing them a couple of different ways. We're doing total annual costs per facility, and also normalized based on, say, surface area or treated volume. This particular table is just the total annual cost to get a big picture of the range of costs for different facilities. And I would tend to go with the median on this type of a summary. So you can see the column there that gives you some different numbers for different BMP types. And I blocked out the manufactured device min and max because those were pretty extreme ends of the spectrum. And I think that that's one of the challenges with taking data from third parties and putting it together, is sometimes you do get these numbers that require some further follow-up to make sure that they're real. And so this is the type of table that we'd be producing. So that's kind of a snapshot of where we are on the reporting protocols. We hope that local governments can use these to help track their actual maintenance costs, and can use this information locally to support better long-range planning activities and budgets. And we would like to keep populating this publicly accessible national cost database to serve as a resource to the stormwater community nationally. And we hope that we'll be able to keep providing useful data synthesis products as the database is further populated. So with that, I will turn it over to Ruth, who will give you some hands-on thoughts about what she's seeing in Lancaster, Pennsylvania. So Ruth, are you there?
I'm here, thank you. I was just waiting to be unmuted.
Okay.
Good afternoon. Thank you again. As Jane said, I'm really happy to be part of this webinar this afternoon. So I'm going to talk a little bit about what we're doing in the city of Lancaster in terms of really getting our house and our cards in order so that we can be more consistent with tracking and reporting some of those O&M costs so that we can also be a fully participating member in the BMP database and an active user of the Classic tool. Jean, I'm just going to say next slide whenever you're ready. So a little bit of context, Lancaster, Pennsylvania is pretty much the one of the lowermost counties in the Chesapeake Bay watershed. So we are very heavily influenced and regulated in terms of our water quality. So green infrastructure is playing a large part in the city's water quality obligations, as well as the city's role and function within the county. We're a very old city. We've had people living here since the late 1600s. We were incorporated finally in 1742, and we're very, very densely populated. So we've got about 60,000 people in about 7.5 square miles. And to make things even more complicated, we have both a combined sewer system and a municipal separate storm sewer system. I say complicated with the caveat that when we're doing things in an integrated fashion, in the manner that Lancaster City is doing them, whether it's a CSO or an MS4 doesn't really have that much of a difference in terms of green infrastructure as far as installation, siting, operations and maintenance, and so on. Next slide. So green infrastructure is basically the things that you're seeing here. They're designed to infiltrate, evaporate, transpirate, capture, and or reuse. And you can see by the photos on your screen that we're doing that in a lot of different places. Pretty much anywhere there's an opportunity to retrofit as part of a redevelopment project or included as part of a capital improvements project. If you want to go ahead and next slide. I think Lancaster is a good example in terms of what we're able to do because we have a very, very small staff and we're also very growing. So in 2011, the city developed its green infrastructure plan and set about installing some demonstration projects. Over the course of the next 3 years, we continued with demonstration projects, established a stormwater management bureau, as well as created a new stormwater management ordinance and a stormwater management fee. Since 2014, we've hired some additional staff. So now I have 2 field technicians, a junior engineer, and a planner on full time. And we're responsible for not just working with our developers and consultants, but also with the rest of Public Works and our economic development folks to make sure that stormwater, wastewater, and drinking water are all integrated to the extent that they can be. To date, we have over 60 projects in the ground. We have another 160 plus in design, and those lists are always growing. Next slide. So one of the main focuses I'm going to have for this presentation is going to be on bioretention. We have a lot of surface features and we've learned quite a bit in terms of what the operations and maintenance obligations are for those surface features. This is a snapshot of one of our projects early on. Currently we have about 75 rain gardens. I think we've installed about a dozen more since this slide was prepared. They're on public property and are in our parks right away, and all of them are maintained by city staff. Next slide. I will note that we do have some volunteers who are interested in maintaining rain gardens through our Adopt a BMP program. We've had some success with that. It's been slow to catch on, but I'm happy to talk about that later. So moving back to our 75 rain gardens, in terms of our inspection and performance monitoring, we have recently developed a green infrastructure operations and maintenance plan that goes along with our green infrastructure monitoring plan, both of which are available on the city's website. And what we look for primarily is the number of gallons intercepted or managed annually before stormwater enters into any of the city's gray infrastructure, conveyance infrastructure. We also look at the number of stormwater permits and stormwater management fee credits we provide every year. And at the end of the day, really what we're looking for is volume and nitrogen, or volume and nutrients removed. And we do that by inspecting and monitoring. Well, by inspecting all of our BMPs every 4 to 6 weeks and monitoring them at least once every 3 years. And we look to make sure that they are installed and maintained properly. So we do inspections before, during, and after construction. We make sure that they are maintained over time. And we try to be very adaptive and dynamic in terms of making sure that what we're seeing in the field is not just addressed, but also the root causes are identified so that we can hopefully minimize the maintenance in the future. Next slide. This is an example of our monthly inspection form. When we first started doing operations, maintenance, and inspection, we were doing things on paper. We are currently working to develop a tablet-based or an iPad-based, we're not sure which yet, which technology, but a mobile system of incorporating these inspection forms into our asset management system. And we are most likely going to be using the Survey 123 that Jane explained was being used elsewhere. It seems to be very easily adaptable, no matter to what program is being used or to what input you want to have in there. It's highly customizable. Next slide. Our regular maintenance procedures are pretty straightforward. We typically do weeding on a monthly basis during the growing season. We have staff out now who are actually doing the August weeding of these rain gardens that you can see in this photo. We also have regular trash and sediment removal. That's probably one of our largest and most frequent activities. We also have regular replanting of dead vegetation. We had a little bit of a challenge last year in that we had more rain than we've ever had in a 12-month period previously. So that did, it impact our maintenance frequencies and our ability to go out and maintain them. And it also did cause some issues with plant survival rates. This year, we're having a little bit of an opposite problem. Some of our newly planted rain gardens are actually really suffering from the droughty periods and the fact that it's been really hot in between rainy periods. So we're trying to find that balance with some of our new installations. We also look at our regular inlet and structure cleaning. Usually we have bolt-on tops, so it's not that common or often that we see things that are inside those inlets and riser structures that shouldn't be there. But we have seen a few interesting insertions into them. We'll just leave it there. Next slide. So, like I mentioned earlier, we try very hard to learn from our past mistakes. And this is going to be very much a conversation of what we've learned and how we are taking that and adapting it into our operations and maintenance, tracking procedures and how that's impacting us on cost. So the photos that you see here are 3 rain gardens that were installed as part of the pilot project process that I mentioned earlier. And you can see in all of these photos that there is some very severe settlement of erosion. There's also ponding water that is not evenly distributed. And in the far right, you can see that the low flow channel is doing an amazing job at being a low flow channel, but those plants on the upper slopes are a little bit too high to really serve much of an effect in terms of what the city was expecting. Next slide. So one particular project that I'd like to talk about is the Plum and Walnut intersection. Anybody who's ever been to Lancaster may know that the Lancaster Brewing Company is at this intersection. And if you've not been to Lancaster, please feel free to visit. First beer's on me. But as you can see in the photo that's here, the street that's running basically directly up and down is Plum Street, and the one that bisects through the middle is Walnut Street. Walnut Street is one way into the city. It is pretty much the gateway into the city. And you can see that there's a lot of pavement in that intersection, including a large concrete elevated curb, as well as what appears to be an acceleration lane coming from the top and headed to the left. Unfortunately, that's exactly what it was used by. People coming down from the top would make a right and try to beat traffic coming through that intersection. So we had a lot of vehicles that would be parked along that upper left portion of the screen, who would have mirrors damaged or doors taken off, very significant traffic issues. It was also an intersection where we had a high rate of speed limit exceedances in an area where we obviously wanted to get more pedestrian traffic towards the business there at the brewing company. Next slide. So in 2012, whoops, if you can just go back. There we go. So in 2012, we took the opportunity to retrofit this intersection with 4 large rain gardens and some porous, I'm sorry, 2013 it was finished, and some porous pavers. And you can see that the rain gardens are primarily on the left and uppermost side of the screen, as well as 2 large linear ones along the bottom side of that intersection. One thing I do want to point out, because I think it's a neat feature of this project, is the small half apple shaped area directly in front of the rain garden or the brewing company building itself. That's actually public right-of-way that is now being maintained by the brewing company for the city as a green infrastructure facility, but it also serves the dual purpose of being their outdoor beer garden. One more reason why that first beer is on me. Next slide. So this was the original planting. You can see that it's pretty sparse. There's a lot of mulch inside those rain gardens, and the slopes nearest the curb are relatively steep. So a lot of the water that's intended to be managed by the plants isn't actually reaching the plants at all. The planting palette was something that we're certainly happy to use where we can. It involved a lot of shrubs and grasses, mostly specific to Pennsylvania. But the bioretention mix was not a native Pennsylvania mix, so that was one count against the plants. This is also in a heavily trafficked area that sees a lot of road salt during those heavy mixed winter storms. So there was a lot of road salt influence. And just as a side note, the mulch was very difficult to keep in place in the fact that it floated, and most of it ended up either downstream or being picked up by our street sweepers. At the end of this first growing season, what happened was almost all of the plants in these facilities had died. And we did track that back to the fact that the soils were not appropriate for the plants that were placed in there. And they were heavily influenced by road salt, so the pHs were a little off in terms of those plants. Next slide. In 2014, we worked with a woman named Claudia West, who wrote a fantastic book called Planting in a Post-Wild World. And we took a look at the soil profiles that were specified for this particular installation, looked at the sand content, and developed a palette that included more coastal mid-Atlantic species. So not necessarily Pennsylvania native, but very regionally native. We also wanted to make sure that they were herbaceous plants that were typically grow less than about 36 inches to maintain site clearance, because you did see some of those porous paver areas. We had a much denser planting plan, and we did not use any mulch. Pretty much the reason for the mulch was because we didn't want to deal with it washing out of the systems, but it also really wasn't required with the dense planting plan that we had. 5 years later, the plants are absolutely thriving in the sandy soils. They seem to be holding up very well to salt exposure, despite the fact that we have had some relatively icier winters than in recent history. We've also gotten a few other retrofits in part of these areas, and we've also learned quite a few lessons from this particular project. So again, in 2014, we replanted. The plant palette is doing amazing. Our staff have adopted the practice of doing significant cutbacks of this in the late summer, and then again in the late spring. We've seen an increase in pollinator species across this particular system around the entire intersection. And it seems to be doing better and better every year. Next slide. So after our first, pilot project lesson learned and retrofit, we also wanted to take a look at what other items might be impacting the performance of this system. And we didn't have to look very far. There was a private alley that actually ran adjacent to the brewing company that you can see pictured here. It was unfinished, unpaved, and unmaintained. And when it would rain, it would bring a lot of gravel and sediment into that bioretention system that you can see, or that you saw on the previous slides. Next slide. So what we did here is we worked with a grant funder specifically to work with private property owners, because again, I mentioned this is a private alley. The city does not own it. We still do not own it, but we worked out agreements with all of the property owners to go in and make improvements here so that we could, one, address the additional stormwater which was coming off of this particular adjacent site, and two, increase our volume capture and pollutant removals for this particular project. So this project actually added about 500,000 gallons of stormwater that we're intercepting from our system every year, and it improved the conditions in that bioretention cell downslope markedly. So next slide, you can see some of the early or legacy influence from that unfinished alley. These systems were originally designed without sediment forebays. So when that sediment was coming down here, it had nowhere to go. It would often settle out in these small cobble channels that were designed to be low flow channels, and they became cemented in over time. So we really worked on developing a way to move around that, and the easiest way to do that we could do in-house that would also help us save on those maintenance costs would be to retrofit it with a forebay ourselves. Next slide. So you can see here there's just a simple markup of what we did. We had our field staff go in and remove a few of the cobbles, replace it with a poured concrete forebay with some energy dissipation practices in there, making it a lot easier for our maintenance staff to go in with a flat edge shovel to remove the accumulated sediment. And it's also more readily visible. So when these forebays begin to fill up with sediment, it's easier for my inspectors to say, hey, there's a problem, or for our maintenance guys to say, oh, this is one that we have to get on right away. Next slide. And you can see the difference in this slide and in the next in terms of what a difference those forebays made. So in the left picture here, you can see that there's a lot of sparse weeds growing. You can see some of the cobbles poking out. It's not a really effective, or for that matter, pretty piece of this particular rain garden. On the right, you can see it retrofit with the forebay. This is coming down at a pretty significant slope, so we wanted to make sure we had adequate settling time as well as velocity dissipation. And even though it's very early in the growing season, you can see that this one is doing much better despite having a lot of the surface area covered with concrete. Next slide. A very similar situation here. The photo on the left was the initial installation, and the photo on the right was our retrofit. You can see that we were able to eliminate all of the cobbles that were in there. So we were able to increase our vegetated surface as well as improve the internal, the entrance hydraulics here by having those velocity dissipators raised through there. Again, protecting the plants from sedimentation and making that a flat surface for our folks to go in and take a shovel to. Next slide. So this is these are just a few pictures of what the retrofit looked like. And if you wanted to go to the next slide. And the next. These are, again, just process photos showing our folks, our field staff doing these projects with tools that they have on hand. So the maintenance practices aren't particularly difficult. They're something that our folks can handle relatively well. And they did an amazing job for it. And you can also see that the finishing was done in-house, and they've really taken ownership of this system, which is also a benefit. Next slide. What the previous photos didn't show were the unanticipated maintenance activities. So the red SUV in the upper left of this particular photo was apparently trying to make a race course out of our rain garden. I'm not sure exactly how he ended up there, but there was no damage to his car. No leaking of fluids into our system, but you can see in the foreground that he did take out a large section of one of the weirs between the rain garden sections, making it, again, a little bit more challenging for us in terms of maintaining it, making sure that it was functioning properly. But we were able to stabilize and in effect recreate the weir with silt sock until we had a chance to go in and repour that with concrete forms. The next slide is one of our additional retrofits. I'm sorry, this was a design that was completed as a result of some of those retrofits, in that this was originally designed by our consultants to have that traditional cobble low flow channel through the middle with no formal forebay in it. We approached them with our concerns and walked through our retrofits with them, and this has now become one of our standards. And you can see it's pretty much the same. We've got a nice flat concrete pad for our maintenance guys to go in with a flat edge shovel, as well as the velocity dissipators and some fall in between those velocity dissipator rows. Next slide. Crystal Park is another one of our retrofits. This one was a bit more challenging. You can see that there's some issues with sedimentation. There's also some issues with flow paths where the water might be going. You can kind of see in the top right picture that that inlet is set significantly higher than the inflow curb cut, and water would actually come through this intersection far enough that it would bypass that inlet and actually spill over the curb. The plants also look very similar to what you might have seen in that first attempt at Plum and Walnut. This was built around the same time. So it was the same kind of issue in that we had the wrong plants for the wrong soils, but we also had some more grading challenges in this one. Next slide. Just a few photos showing what some of the challenges were. Again, you can see there were some grading challenges. Water was ponding and actually coming back out of the systems. You can see water in the rain garden without ever overtopping either of the risers before it would overtop the curb. So we really had our work cut out for us. We wanted to make sure that we were being attentive and doing what we could to alleviate some of the maintenance frequencies in this particular location. So, next slide. We took a look at the original plans for this particular project, and we looked at some of the technical components. We wanted to make sure that we were being as effective and cost conscious as we could be. So we looked at replacing the soils, adjusting some of the outlet heights, and in this case specifically, we engaged the neighbors. This being a rather low income portion of the city and a rather heavily used park, we wanted to make sure that there was some community buy-in to it, which was really helpful for us in the long run. And now we have a community leader in this area who is taking it upon himself to educate the local community about what these are, how they function, and why they're in the place that they are. Next slide. In terms of corrective actions, we did quite a few. And there's actually been some additional improvements done to this intersection since. And all of those improvements have included energy dissipators that are designed with input from our field maintenance staff, replantings that were done at a much denser concentration than was originally, and it also includes elimination of the low flow channels. What we're finding is actually that they're functioning a lot better in terms of both plant health and stormwater management by eliminating those low flow channels, which were basically acting as small little bypass channels. Next slide. Here you can see some of the after work that was done, and all of this was done again in-house with city staff. All of the retrofits, the concrete pours, the drop in elevation of the surface, the inlet structures, and the plantings were all done with city staff, again, to ideally save on costs. And I'll talk about the costs once we get towards the end. But you can see here, in the rightmost photo, our field staff working with the landscape architect, and they're laying out the plan, laying out the plants, in the concentration that they are designed to be planted in. And if you go to the next slide, you'll be able to see what that dense of a planting looks like, as well as the soil control matting that we used to hopefully keep those in place. One other project where we've had some similar challenges was Rodney Park. This is 2 blocks away from Crystal Park. You can see here we also had some challenges with the low flow orifices. A few of the incoming drainage areas were scarring out. You can see the curb cut drain along the right side of the photo and the sediment that was bringing in. And you can also see that there's where the water was ponding was primarily in that center point of the rain garden instead of being distributed out. And on the next slide, you'll be able to see what it looks like today. Again, we did the same practice. We took a look at what we had planted in there, what the soil types were to be planted in there, and what might need to be replaced or re-envisioned. So we did another grand planting. This was replanted by in-house staff last year. So this is 1 year's worth of growth. And we made it a point to incorporate as many pollinators as we could while maintaining that 3-foot maximum elevation on the plants, as well as reedy material. And this will be on the same frequency in terms of drastic cutbacks in the late spring and late fall. On the next slide, you can see just a little bit of the variety of plants that you might see in some of our rain garden retrofits. And this is pretty common. We're trying to standardize not necessarily a specific plant palette, but a plant list that will help us not just ensure performance, but also help our maintenance staff in terms of identifying which plants are supposed to be there and which are not at different phases of the growing season. So on my last slide, I will just leave you with some of the lessons learned. Basically, it's just selecting the appropriate plant material. And I am an engineer, and I will admit that they did not teach me plants when I went to college. So I cannot work without a landscape architect or someone who knows plants. Making sure that the plants are suited to the bioretention soils that you're specifying is just so vital. Making sure that you're looking holistically, not just at the block your project is on, but at the entire drainage area. When you're doing your designs, design with maintenance in mind. Always try to get the opinions of the people who are going to have to maintain this in the field at the end of the day. Do your regular inspections. If it's not working, try to figure out why it's not. And then once you've figured out why something isn't working, retrofit to fix that problem, and then incorporate those changes into any programmatic or design documents that you might have going forward. To summarize, we have a very, very small staff here, despite a growing green infrastructure program. We have multiple BMPs on the ground, and we are working, like I said, with several folks to bring our asset management system up and running so that it will be compliant and consistent with those data input measures that Jane spoke of earlier, that will be an input into the BMP database, as well as some of our costs. We don't have the costs broken down just yet, but our total estimated operations and maintenance budget currently going into fiscal year 2020 is about $330,000. That includes street sweeping, subsurface inspection, subsurface maintenance, including jetting and televising, watering, and the tech time to input these into our asset management system. If you have any more questions or want information from me specifically, I would say input those into the text box and let either Jane or I or Ben know who they're for, and we'll be happy to answer them. Thank you. So not seeing any questions, I will let Ben or Jane take over from here.
Ben, I don't know if you have any closing remarks for the webinar today, but Ruth and I both appreciate the opportunity to present.
Yes, very much so. I appreciate the opportunity to share our story with you. And again, if you have any questions, I know that Jane and I would be happy to answer them. So for those of you who are on the webinar still, I do apologize. We're having a little bit of technical difficulty in getting Ben unmuted, so just bear with us. So while we're trying to figure that out, and we do have 2 minutes left, there's a question that I see is coming in, and it says, was there a design manual that was utilized for the 4-bay retrofits? The answer to that is, at the beginning, no, we did not. We just took a look at some of the inflow hydraulics based on the volumetric design storm that was used to design that practice. And we made some very broad generalizations to come up with just a rough estimate of what those 4-bay lengths should be. Since we did that, we have developed a green infrastructure design plan. Again, that document is also available on our website, and that includes 4-bay sizing for all of our newer projects. There's another question that says, do you have any experience with any proprietary 4-bays? For example, Rain Guardian, any experiences or recommendations? Right now, the City of Lancaster does not employ or have any proprietary 4-bays installed. We do have several projects coming up that have potential to put those in. We would be open to that, but right now I don't have any experience with that. Jane, did you?
No, I don't know that I have any more to add on that topic, but I would say that the 4-bay, the ease of maintenance in 4-bays is definitely something that has been really important in the Denver area. Mm-hmm. And so I really enjoyed seeing your presentation and the ideas that you had about the 4-bay there. Another issue that we've had here in some small towns that have small rain gardens in residential areas is that issue of local or the residents filling in the rain garden, or the city going out to inspect and it not being there anymore in some of our smaller communities.
We also have some of that, which is again why we've had a little bit of success with our Adopt a BMP program. It seems to be gaining popularity, so we will see how that goes, but it's been really interesting to see which groups have stepped forward to sort of take ownership of a lot of those within the public right-of-way. And then I think the last question that I saw is there any signage or information available to the public at the brewery site? Seems like a great place for signage. Yes, there is. There is a fantastic little photo display of what the art piece associated with the brewing company is, which I did not mention in this particular presentation, but we have a 700-gallon cistern that actually serves to irrigate the stormwater practice in front of the brewing company that takes its runoff from the roof of the brewing company. So we have some information about the art, the installation there, as well as what the installation is and how it functions from a stormwater perspective. We were also able to partner with the brewing company to have interactive placemats that were available to families who would bring their children to the brewing company for dinner. That included a word search and other activities focused around stormwater and the installations at the brewery specifically. And with that, I think we're about 2 minutes over time. So again, thank you on behalf of Lancaster City, and I will say for Jane also, we are incredibly happy to have been part of this webinar, and I look forward to answering any questions that you might have. Feel free to email me. My information is on the screen.
Thank you. Have a good day.